Okay, so no vertical line will cut that graph in more places than one, so it passes the vertical line test and represents a function. All right. Now, once again, moving left to right, the way you read correctly, you do read left to right. All right. Moving left to right, you notice the graph is increasing, decreasing, constant, increasing, constant. So no surprise there. Okay, a couple of things to talk about regarding these intervals. Number one, I just use my x-axis values to indicate the interval. I use values on the x-axis to indicate the interval. So let's check out one of these intervals. The first one is obviously increasing. Now notice it is increasing from where x is 10 to where x is, negative 10 to where x is negative 8, right? That's what I mean by use the x-axis values. Just use your x values. So from where x is negative 10 to where x is negative 8, the thing is increasing. Those are the values I use to indicate the interval. So my first increasing interval is from negative 10 to negative 8. Now as I write that out, my second point becomes obvious. I use only parentheses to indicate these intervals. I use only parentheses to indicate these intervals. Let's think about 1. Here's the 1. Hey, that point right there. See that point, negative 8, 2? Is that part of the increasing interval, or is that part of the decreasing interval? Both. Or you could say neither, right? But it can't be one or the other. It can't be chosen by one and not the other. And it can't be in both of them. So what we do instead is to say, hey, that's a turning point where it stops increasing and starts decreasing. So we're going to leave it out altogether. We're just going to talk about the part of the graph in between those turning points. So from negative 10 to negative 8, we're going to use parentheses and say that's the interval in which the graph is increasing. Okay, my next part of the graph is what? It's decreasing, right? From where x is to where x is, okay, so where x is negative 8 to where x is negative 5, so that's how I'm going to indicate my first decreasing interval. Negative 8 to negative 5. Next one is constant from
negative 5,
negative 1. Everybody see what we're doing? We're just using the x values. We're just using the x-axis values, which is your first coordinates. So from where x is negative 5 to where x is negative 1, it is constant. Next one is increasing from negative 1 to 2. Next is constant from 2 to 7. Hey, is that a problem? Is that all right? That's pretty straightforward. That's just some definition. Increasing, decreasing are constant intervals on a graph, parts of the graph where it's increasing, decreasing, or constant. Two things to remember. I just use x-axis values It's from where x is this to where x is that. Secondly, I only use parentheses. I don't use my endpoints or my turning points. I don't include those in the intervals. So parentheses all the time on these. Now that doesn't say parentheses are always going to be on every single interval, but the intervals that talk about increasing, decreasing, or constant intervals, yeah, always parentheses. I mean, you've used intervals that has brackets on it, right? Done that more than once. But if you're talking about increasing, decreasing, or constant intervals, always parentheses. That's not bad. Next concept involves something we just looked at. And that's an observation that, hey, this graph stops increasing and starts decreasing at a particular point. And this graph stops decreasing and becomes constant at a particular point. So we're going to be looking at those particular points in terms of a definition called a relative maximum or minimum point. And you can probably tell what a maximum point is. Maxima is just the plural of a maximum. A relative maximum is the top of a curve, right? A relative maximum is the top of a curve. A relative minimum is the bottom point, the trough of a curve, a very low point. There's the crest of the wave, or the bottom of the trough, however you want to put it, high point, low point. But notice this key adjective here. It is a relative maximum point, a relative minimum point. Relative meaning, in relation to those points around it, this is the highest point. Hey, in relation to those points I've circled, and by the way, how many points on the graph have I circled? Have I? How many points on the graph have I circled?
Infinite.
An infinite number of points. I've just only named one of them, but there are an infinite number of points. Hey, every place you can put your pencil down on that graph is a point of the graph. So I have literally circled an infinite number of points, and there is a highest point out of that infinite number of points. That's called the relative maximum. And here's a concept I need to remember when I'm talking about relative maximum points. Use y values. Hey, that's the up and down value, right? Y values is the up and down, the high or low point. Use y values to describe maximum or minimum points. So in this case, I only have one, so it's a relative maximum. Our relative maximum is, the y value is 7. That's the y value, right? That's how high it is. It's 7 up. Hey, what's my relative minimum?
-2.
-2. I find the relative minimum. It's right there. It's the lowest point out of that infinite number of points. And I use the y value. It's -2. Now here's a concept you need to remember. Relative also means this does not have to be the highest point in the entire graph. Let me finish off this graph. Let me finish it off this way also. Is 3 -2 the lowest point on this graph? No way. it goes infinitely down. But relative to those points right there, it's the lowest point. And again, negative 7, 7 is not the highest point of the graph. That arrow indicates it continues to go infinitely up. But it's the highest point out of that bunch of points. Here's another way to think about it. Anytime the graph stops increasing and starts decreasing, there's going to be a relative what? Maximum. Anytime it stops increasing and starts decreasing, there's a relative maximum. Anytime it stops decreasing and starts increasing, there is a relative minimum. Okay, so that's basically the concept. Hey, it stopped increasing and started decreasing, there must be a top. Hey, it stopped decreasing and it started increasing, there must be a low point, a minimum. So just remember that. Use the y values so that you're not confused if I say what is the relative maximum and I don't give you points, but I just give you numbers. 2, 4, 7, 12. Pick the y value from the point. Question there? All right. Another concept in this section is called zeros of a function. We did this? We did zeros of a function? All right, so we've already done zeros of a function. You know that zeros of a function is where, what is 0? Y is 0, right? So your strategy is set y equal to 0 and solve. Let's do one more like this. I found an interesting one, so let's do this. I'm sorry, I wrote down wrong.
So is that just x cubed?
Just x cubed. That is tornado x cubed. That's, I wrote it down again wrong. That's 36. I had a traumatic day yesterday. All right. Anybody ever had an MRI? They put you in a little tube, put a clamp down on your chest, and say, you're going to be in here in an hour. And don't move, and hear some loud noises to explode in your ears while it's going. I lasted 30 seconds. Okay. 30 seconds. I was proud of that. I didn't realize I was claustrophobic until yesterday. They're going to do it again next Wednesday with some happy juice. So that I don't care where I am or what's going on. Take all the pictures you want. Here I am. That was not my proudest moment, but I tell you what, I'm still breaking out sweat and thinking about it. So if I write down an X instead of a 6, you might understand. All right. Hey, what are we going to do with this guy?
Factor it.
Factor how? By grouping. What do you want to group together? First 2, okay. Let's put them together physically. And if it's a 0 of a function, I'm letting f of x equals 0, right? That's the idea. F of x is the same as y. So I'll let it equal 0. What do you want to take out of this guy? These guys?
X squared